Hello all, welcome to the video lecture in Hamming coding in computer networks. Hamming coding is an error detection and error correction code. This error detection and error correction codes performs both the operation of error detection and also error correction. Right? This has a code word, that is the data bit will be added with extra bit which is known as redundant bit, and then it will be sent as a code word. Here extra bit is being added, that extra bit is the redundant bit what we are going to add in this. In order to find the redundant bit, we have the formula 2 power r greater than or equal to m is the message bit what we are going to send, r plus 1. So this is the formula which I will be using in the upcoming problem. So say for example, if our data bit is equal to 7, then the number of redundant bit is equal to 2 power r greater than or is equal to 7 plus r plus 1. If we substitute in this, we will be getting it as 4. The 4 is the number of redundant bit that we are going to add. So they are placed in such a way that 2 power 0, then 2 power 1 which is nothing but 2, then 2 power 2 which is nothing but 4, then 2 power 3 which is nothing but 8. This is how they are being placed. Right, now step 3, we have to find the values of R1, R2, R4 and R5. In order to find the values of R1, R2, R5, we are using this formula. That is R1 is nothing but 1, 3, 5, 7, 9, 11. That is, we have to look here. In this values, if you see what are all the values are getting 1, that value will be placed here. For example, for R1, the 1, 3, 5, 7, 9, 11 are the values which is having one value. Similar procedure for is followed for R2 also. The R2 values are 2, 3, 6, 7, 10, 11. These are all the value for R2. Then R4, this value. So with this we will be with this steps we will be going to solve. We are going to solve a problem, that is generate a Hamming code for 7 bit. This is the data bit what we are going to have. First step, we have to find the minimum number of redundant bit that is required to send. That is 2 power r greater than d plus r1 plus 1. This is the formula what we have. So if we substitute 2 power r greater than or is equal to 7 plus r plus 1. Say for example, first if I am going to substitute r, 2 is not greater than or equal to this value, so this cannot be taken. Similarly, if I take 4, 4 is not greater than or is equal to 7 plus 2, hence this can also be taken. So r, this is going to be 8, this cannot be taken. So when we come to this can be taken. This is how we are going to find the value of redundant bit. So the redundant bit value what we will be having is going to be 4. So now as we have already seen for 7 bit and 4, I am just putting this block where R1, R2, R4, R8 has to be found. The values of R1, R2, R2 are found by the below formula what we have. Now I am just going to place the value 1, 0, 1, 1, 0, 0, 1. Look here, this is the value that is being given 1, 0, 1, 1, 0, 0, 1. So I have just placed it as 1, 0, 1, 1, 0, 0, 1. That's all. So now I have to find the value of R1. In order to find the value of R1, I'll be using the formula that is being previously shown. That is, here these values will be, these are all 3, 5, those value which I have stated already. These values will be added. The summation of R1 value, these values are added. That is R1 plus 1 plus 0 is going to be 1. Again adding this 1, it is going to be 0. Again it is going to be 0. By adding this 1, it is going to be 1. Hence this value is 1 here. Similarly, if you look for this, I am going from this side. 1 plus 1 is going to be 0. 0 plus 1 is going to be 1. Then 0 plus 1 is going to be 1. Again 1 plus 1 is going to be 0. Hence it is 0. So similar approach for R2 also. Right? R2 is going to be 0. 1, 1 is going to be 0. This is how we get the value. Now I have inserted these values which were written as R1, R2, R4, R5. I have inserted these values here. These values are found and this code word will be transmitted. And this can be tested by using Hamming formula in the receiving section. As of now, we have performed Hamming coding encoding process. That is, we have transmitted the code. In the next session, we will be seeing about how to find whether it is having error or not. So I'm going with the same example what I have taken. So if we see here, we can see both the values. See 1, 1, 0, 0, and again it is 1, it is 1, it is 0, it is 0. Here it is 1, here it is 0. See here, in my transmission, that is my received bit having an error in the 5th bit. Right, my received bit is having error in its 5th bit. The value of 0 is being changed to 1. So now I am going to use the Hamming method to find out which bit is having error, and also I am going to perform the correction of it. So in order to find the value, we are using this formula. As we already know this formula, I am going to substitute these values and I am going to find this value. So positioning of this is, we all know the position. By adding 1, 3, 5, 7, 9, 11, I'll be getting 1. I am getting 1 here. And in order to find the R2 value, I do this, I add this, I am getting 0 value. Similarly, if I am going for R4, this value is going to be 1 here. Similarly, R8 going to be this value is going to be 0. Now if you get all these values to be 0, then that means it is error free. As in this case, I am getting 1, 0, 1. So I have to go from this side, that is 1, 0, 1. It can be written as 0, 1, 0, 1. What is the value of this? What is the value of this? The value of this is 5. That indicate that error is there in the 5th bit. So obviously what we can do is that 5th bit, as 5th bit value is 1 now, that is in the received bit, we are having 5th bit value to be 1, that can be changed to 0. Hence now this this data is error free. Here we have performed both the error correction, deduction, and also error correction. This is how Hamming code works. Let's see in detail in the next lecture. Thank you.